All right, let's do variations of molecular geometries or shapes that are all based on 6 electron domains or octahedral structures. Now, again, remember, if there are no lone pairs, so let's say these are 6 bonds and 0 lone pairs. If that's the case, we see what we get. So we would have a 4-sided pyramid on the top. Let me go ahead and draw that. A 4-sided pyramid on the bottom, that gives us 8 sides. We call this octahedral. And that is both the electron domain geometry and the molecular geometry, since there's no lone pairs. Okay, now let's start adding ghosts. Lone pair ghosts, things we can't see. We're not going to see those lone pairs. We can't see atoms either, but we can map them out. We're going to ignore the lone pairs and talk about the geometry of the atoms present. Now, for this one, it does not matter where you put your first lone pair. The angle from the top and bottom to the ring is 90. The ring split 4 ways is also 90, so it doesn't matter. For me, I like to go ahead and put it on the top if I don't have to make a choice. So, first variation. We're going to still do 6 domains, but this will be 5 bonds and 1 lone pair. If we have 5 bonds, 1 lone pair, I'm going to stick my first lone pair wherever I want it. I'm going to go ahead and put it on the top. First lone pair goes here. Now, what is left over? What's left over looks like a pyramid. It's a pyramid with a square base, not a triangle base this time. Fancy name for pyramid with a square base, it is called square pyramidal. Okay, so that's your first molecular geometry. Now, what if we still have 6 domains, but 4 of those are bonds, and 2 of those are lone pairs? All right. Does not matter where you put your first electron ghost, your first lone pair, because they're all the same angle. I'm going to ghost out my first one. But it does matter where you put your second ghost. Lone pairs need a lot of space. So if your first lone pair goes on the top, we want to give the second lone pair as much room as possible. We're going to put it opposite of it. Now, if we do that, what are we left with? We're left with a square that is flat. So the name of this shape, well, it's square, and the fancy word for flat, planar. Square planar. All right. Let's go for 3 ghosts, 3 lone pairs. Molecules that have 3 bonds and 3 lone pairs. First lone pair, doesn't matter. Ghost that out. Second lone pair, does matter. Make it opposite. Third lone pair, okay, I guess I got to put it in the ring around the middle. Third lone pair. What am I left with? A line and then another line 90 degrees to it. This is T-shape. Looks like a T. All right, let's go for our last variation. Last variation has, oh dear, 4 lone pairs, and it has 2 bonds. So it still has 6 electron domains. Now we need to ghost 4 things out. So I'm going to ghost out my top. Second ghost, second lone pair goes on the bottom. Third lone pair, I'm going to put it here, but where does the 4th go? Opposite it. 4th one goes opposite. That leaves 1, 2, 3 atoms that are all in a line, and therefore we call it linear. I hope that helps. If you really know your molecular geometries, you should be able to repeat this just with a pencil, a paper, and your head. Good luck. Keep practicing.